Welcome back. I am Ms. Warnell. We're going to continue our discussion of matter and change with emphasis on this video on classification of matter. So matter is anything that has mass and takes up space. Takes up space would be volume. And so we're going to be classifying matter. So first we want to make sure that you understand what matter is. So anything, when you think about it, if it has a mass or it's going to take up space, it would be considered matter. So rock has mass. X-rays is electromagnetic radiation, does not have mass. Air is matter. Air, even though you can't see it, when you take a deep breath, you know that it takes up space because it fills your lungs. Heat would be non-matter. Heat flows from warm objects to cooler objects. Keep that in mind. Juice definitely has mass. That would be matter. Energy would be non-matter. Light, non-matter. Salt would be matter. It has mass. And then ice is mass. And then we have radiation, which is non-matter. There's lots of different types of radiation. Three states of matter and their properties. So matter falls into these three states, which we're going to study in this class, not focusing on plasma, but solid, liquid, and gas. So the structure, solids are tightly packed together, liquids are less compact, and then gases are loosely compact. Compressibility, that's the ability to kind of squeeze it in together. Solids, you're not going to be able to do that. Liquids, if you try to press down on the liquid, it's going to splash. But a gas, because their particles are spaced out, there's a lot of empty space between them, you can compress a gas. And this is how we're able to store oxygen in tanks and whatnot. Motion of particles, solids are barely moving, they're vibrating in space. And when we're talking about that vibrating in space, we're talking about at the molecular level. Liquids, they're moving, the particles are moving a little bit more than solids. And then, of course, gases are moving the fastest of all. Shape, solids have definite shape. Liquids have indefinite shape. You can pour liquid from one place to another. Gas is indefinite, okay, shape. And then volume, you have definite volume for a solid. For liquids, you have definite volume. And then for a gas, you have indefinite volume. Make sure you know the properties of a solid, liquid, or gas. So let's look for a solid. You can see that the particles are moving here. And this is H2O. You can see the oxygen, and these would be the hydrogen. So let me make a little happy face. And they are moving at the molecular level. There's really only one temperature that matter stops moving, and that is absolute zero, and that would be 0 Kelvin. All right. For our liquid water, you see that they're moving a little bit more. They're flowing around. And then for a gas, they're moving a lot. So you can see gases have the most energy, and then would be liquids, with solids having the least amount of energy. So when we go to classify matter, we have to look at it and put it into these categories. So the two main categories are pure substance or mixture. So let's look at from the angle of the pure substance. Pure substance is uniform, indefinite composition. It has one chemical formula. So if it's a pure substance, it's either going to be an element or it's going to be a compound. An element are any of those items, any of those items that we gave you on that periodic table at the beginning of school. It is one type of atom through and through. A compound is going to be two or more of those elements chemically bonded together, like the water. Now, if it's not a pure substance, it's going to be a mixture. And pure mixtures are two or more pure substances that are physically combined, okay? They're separated by physical methods. So there are two types of mixtures. You can have a homogeneous mixture, which is uniform throughout, or you can have a heterogeneous mixture, which does not look uniform throughout. Okay, and another name for homogeneous is solutions. So when we look at this matter, this is just a way for you to tell which it is. So when you look at something, you're trying to decide if it's a mixture of pure substance. First, ask yourself, can it be physically separated? If it can be, then it is definitely a mixture. Okay, and if it's a mixture, then you say, okay, is it uniform? Because if it's uniform, it's going to be a homogeneous mixture, or another name for that, solution. If it's not uniform, it's going to be heterogeneous. Now, there are two categories for heterogeneous mixture: be colloids or suspensions. Now, suppose it cannot be physically separated, then it must be a pure substance. And if it's a pure substance, then you just say, can it be chemically decomposed? So the answer is yes. Like if you look at, say, water, we could break water down into hydrogen and oxygen. Then that makes water a compound. Or what if it cannot be? You're just looking at iron. You can't break iron down any further than an atom of iron, so it would be an element. So if you're, when we're talking about physically separate mixtures, these are a variety of ways in which you can separate mixtures. One, suppose you had some Skittles. You could just pick them out. That would separate them. Suppose one of them had magnetic properties, like iron and sulfur. You could use a magnet to separate them. Suppose you have something like muddy water, sand water. You could use a funnel and some filter paper. Put the filter paper in the funnel, pour the mixture in, and what would happen is the water liquid would come through here to filtrate, and the solid particles would stay behind in the filter paper. You could also do chromatography. You might have done this in biology with with leaves, where you put, in this case this is ink, you put a dot on a black ink or black marker on chromatography paper, and then you put it in some water, some alcohol, and as the water alcohol travels up, it begins separating out all the different pigments inside that ink. And then we have this, which is called distillation. So what if you had two liquids? What it does is it separates two liquids. It separates two liquids. Right, separates. Yeah. I'm not going to spell that. Separates two liquids. So if you had a mixture of two liquids, how would you separate them? If you put them through the funnel, the filter paper, they're both going to travel through the filter paper. So what we do is we make use of their boiling points. Okay. So suppose we have liquid A that has a boiling point of 100 degrees, and we have liquid B that has a boiling point of 75 degrees. So what we would do, so they're both in here, this is a Bunsen burner, we would heat it up to a temperature of about 75. And at 75, B will turn into gas, and it will travel through here. And then when it hits this condenser tube, and you see here there's some cool water going in, it will cool it down and turn it back into a liquid, and so then you end up with B over here and A left behind. So lots of different ways, and there's even more ways than this to separate mixtures. So this is just practice on whether something's heterogeneous or homogeneous. Salt water looks uniform throughout, homogeneous. Raisin bran, clearly can see the raisins. Air, homogeneous, you don't see the difference, nitrogen, oxygen, things like that. Soil, heterogeneous. Brass, homogeneous. It's actually called an alloy, a homogeneous mixture of is called an alloy. Salad dressing, heterogeneous. Iced tea, heterogeneous. You can see the ice, and then salad would also be heterogeneous because you can see those components. So this is a picture sketch of some matter, and we'd like for you to be able to tell whether it's a pure substance or a mixture, if it's heterogeneous or homogeneous matter, if it's an element, compound, or a mixture, and then whether it's atoms, molecules, or mixtures. Atoms is the smallest part. Atoms are the smallest part of an element. Molecules the smallest part of a compound. All right, so in this first one, we have these single items here. They look all single. They look all the same, and they're all single. So that's here. So I would say it's a pure substance. They all look the same. They're the same exact thing. Homogeneous because they look the same. Elements because they're single and they're all identical. And then they're atoms because they're all single and identical. On this next one, we have single items still, but there's different single items in there. So I would say this is representing a mixture because they look different. I would say it's heterogeneous matter. Notice here, I'm asking you to distinguish between heterogeneous matter and homogeneous matter, not mixtures in this case. Heterogeneous because they all look different. It's a mixture here. And it specifically it's a mixture of elements because they're all single. This is also a mixture. I misspelled that. And we can say specifically it's a mixture of atoms. On this one, we have a circle with a triangle, circle with a triangle, circle with a triangle, circle with a triangle. So they're paired up, and they all look the same. So it's a pure substance, they all look the same. Homogeneous matter, all look the same. Compounds, because they're paired up together, and molecules, because they're paired up, and they all look the same. You're going to have to be able to make these sketches, and you're going to have to be able to identify what type of matter it is based on a sketch. This concludes video 3. Make sure you're taking good notes. Come to class with any questions. We look forward to seeing you in class tomorrow.